All right, if you want to see these done, here we go. First, we need to look at the name, and we see potassium chloride. So I have to look that up on my periodic table, and you will have one that's a little easier to read than this, and you can also use your paper one. And potassium is letter K, so your paper one would help you with that. But that is +1, so I'm going to put K +1. And then chloride, if I look for chloride, I'm not going to find it exactly, but I will find chlorine, which is Cl. Remember the anion changes to I, so Cl -1. And then I ask myself, do the charges add up to 0? +1 and -1 do add up to 0, so that means that I already know the ratio, it's a 1-to-1 ratio. And so I'm going to write in the box here, KCl, with no subscripts because that means 1. I'm showing my work by writing the charges, and that's enough here. Now let's try sodium oxide. Sodium is Na, it's also a +1 like K, and oxide is actually oxygen, and it's a -2. So I'm going to write Na +1 or 1+, doesn't really matter, and O2-. Now I ask myself, do they add up to 0? And they don't. 1+ and 2- do not add up to 0. So I'm going to list until they do. And I see there's more negative here, so I'm going to add another Na 1+. Now I ask myself, do the charges add up to 0? 1+ and 1+ make 2+, and then we have a 2-, so now they do add up to 0. So now I have to count how many atoms I have of each, and I'm going to circle them and I count them. 1, 2 Nas, and let's do a different color, and only 1 O. So I'm counting actually how many ions there are, not the charge or anything like that, just how many there are there. And so it looks like it's Na2O, because when there's 2 Na, you put that after that, and then O. Make sure in this box over here, like the finished answer, you do not show charges. You do not see any pluses or minuses, and it's only symbols and subscripts in the formula. Let's try the next one. Just going to give myself a little more room, get rid of this. Now the next one is magnesium nitride. And I see magnesium over here. It's hard to see here, but remember you'll have a better one. Look at your paper one. Mg is magnesium, it's a +2. And nitride is nitrogen, and that's N, and that's a -3. So Mg +2, N -3. And then ask yourself, do the charges add up to 0? No, they do not. So I'm going to look in the one that I have less of, the +2. There's less positives than negatives here. I'm going to add another positive one. And now I have +2 and +2. That makes +4. And now that's next to -3. That's still not balanced out. They don't add up to 0. So since now I have more positive, I'm going to add another -1. And that went up to -6 now together. So I have +4 and -6. So I need more positive again. There's not quite enough room here, but now I have +2, +4, +6. And I have -3, -6. So yes, they add up to 0 now. Because when the charges are opposite but equal, +6, -6, opposite but equal, then they add up to 0. So now I'm going to count. I'll use the red again. We have 1, 2, 3 Mgs. So I'm going to put Mg3. And I have 1, 2 Ns. So I'm going to put N2. I'm just going to use one color so it doesn't look, you don't usually use 2 colors in the formula. So there you go, Mg3, N2. Remember, no charges or anything over here, just subscripts. Let's do the next one. I have aluminum fluoride. So I have to look up my charges. Al is over there in the +3 row, the yellow group. And, sorry, what was it again? Fluoride, F. Fluorine becomes fluoride, so F is in the purple and it's -1. So Al +3. And then we have F1-. So I ask myself, do they add up to 0? No, they don't. I have more positives, so I'm going to start listing some more negatives to try to add up to that. I'm going to list them just over to the side. Hopefully that still makes sense to you. So it's still a -1. Now do they add up to 0? No, because it's 3 plus and only 2 negatives, so I need one more F. And now I have 3 plus and 3 minus as far as my charges. But now I'm going to count how many of those ions I have. I only have one Al, so I'm going to put Al with no subscript. And I have 1, 2, 3 F, so I'm going to put AlF3. Next one, boron sulfide. Boron is over there right above Al in the yellow column at +3. And sulfide is, instead of sulfur, it's in the pink column underneath O, and it's -2. So I have B3 plus and S2-. Now the more you do this, you're going to realize that +3 and -2, or anytime it's 3 against 2, that's where you have the most listing to do. So +3 and -2 do not add up to 0. Since 3 is a bigger number, I have more positive. I'm going to start by adding another negative to my list. So now it's +3 and -4. And so now I have too much negative, so I'm going to add another positive to my list. And now I have +6 and -4. That's supposed to be a 3. And so now I have more positives again. So I keep going back and forth until they add up to the same number, just opposite. And now I have it. I have +6 from the B, 2 B's, and I have -6 from 3 S's. We're going to count them. I'll count them again. How many? 2 B's. So B2. And then how many S's? 1, 2, 3. S3. So notice, kind of like the Mg3N2, we have the most ions when it's trying to balance 3 against 2. I just noticed the last one was different on my worksheet, so I'm going to do this one more at the bottom here, calcium selenide. Calcium, again, was Ca +2, but selenide, Se, is in the pink underneath sulfur, and it's -2. It's selenium, but it becomes selenide. So Ca +2, Se -2. And now I add them up to 0, and they do add up to 0. And so I know I only need one of each. If you want to count them, you can. There's one of each, one Ca, one Se. So that's an easy one. Just remember, it's not Ca2, Se2, because like if you crisscross them, you'll get that, but that won't give you the lowest terms. So the first step is always to see if they add up to 0, because if they do, then you know it's just a 1-to-1 ratio. Remember to see your teacher in office hours or email if you need more help.